and with behalf of the entire legislature, I would like to welcome Dr. James Hansen. We are very honored to have you with us, and by way of background, I'd just like to tell you a little bit about Dr. Hansen and why we're so honored. Dr. Hansen is the director of the NASA Goddard Institute for Space Studies in New York City. My family is Goddard, so I know how to pronounce that, I'm sorry. An adjunct professor at Columbia University's Earth Institute. He is well known for his testimony on climate change to Congress in the 1980s that helped raise broad awareness of the global warming issue. Dr. Hansen was elected to the U.S. National Academy of Sciences in 1995, and he was designated by Time magazine as one of the world's 100 most influential people. That was in 2006. Also in 2006, the American Association of the Advancement of Science selected him to receive their award for scientific freedom and responsibility for his courageous and steadfast advocacy in support of scientists' responsibilities to communicate their scientific opinions and findings openly and honestly on matters of public importance. In 2009, Dr. Hansen was awarded the Carl Gustav Rosby Research Medal, the highest honor bestowed by the American Meteorological Society for his, quote, outstanding contributions to climate modeling, understanding climate change forcings and sensitivities, and for clear communication of climate science in the public arena. The title of Dr. Hansen's address today is, quote, Threat of Climate Disruptions, Implications for Energy Policy and Intergenerational Justice. He will be speaking as a private citizen, not as a government employee, and following his address, he's delighted to take questions from legislators and then from the general public. Following that, we hope Dr. Hansen will also be available to the press. I hope all of you will join me in an enthusiastic welcome to Dr. James Hansen.
Thanks very much for this opportunity to speak with you. And you can see that I changed the title of my talk a little bit, preparing this yesterday. The coal issue is extremely urgent, and I hope to make that clear to you. I always need to start out by pointing out that there is a gap between what is understood about the global climate change issue, global warming, by the relevant scientific community, and what is known by the people who need to know, and that's legislators and the public, the policymakers. Because the truth is, it's hard for people to recognize that we have an emergency, but we have reached a crisis point, which is particularly important for our children. But the reason that it's hard to recognize because weather fluctuations are much larger than global warming is at this time. And yet, it is extremely important because of the inertia of the climate system. We have only experienced a fraction of the ultimate climate change due to the gases that we've already had in the atmosphere. So there's more in the pipeline. And we can't push the climate system to points where the dynamics begins to take over and changes begin to occur that are, that are out of our control. That's the danger. And the bad news is that it's become clear that the dangerous amount of carbon dioxide is no more than 350 parts per million. And we've already reached a level of about 385 parts per million. We can still get back to a safe level, and there would be many benefits in doing that, but it requires us to begin to take actions very promptly. This graph shows the global temperature change over the last century. Its temperature has increased by about 0.8 degrees Celsius, which is about 1.5 degrees Fahrenheit. And most of that warming has come in the last 30 years. Last year, 2008, was the coolest year that we've had since the year 2000. But that is a temporary fluctuation which is associated with the temperatures in the tropical Pacific Ocean. This red and blue diagram at the bottom of this chart shows what's called the El Nino index. When it's red, that's warm period El Nino. This is describing the southern oscillation, the natural fluctuations from El Ninos to La Ninas, where La Ninas are the cool phase and El Ninos are the warm phase associated with upwelling of deep water in the Pacific Ocean. So the last 2 years we've been in a rather strong La Nina, which is the reason for the low temperature last year. The blue line is the global ocean surface temperature. And as you can see, there's a very high correlation between El Ninos and warm global temperatures and La Ninas and cool temperatures. So that's the reason for last year being cool. But as I say, the warming is small compared to weather fluctuations, but if you average the temperature over several years, then you can see the warming effect very clearly. The map on the right shows the temperature anomalies in the first 7 years of this century, relative to the period 1951 to 1980. And yellows and reds are warmer than that long-term average. And you can see that it was warmer than the long-term average essentially everywhere, with the warming larger over land than it is over the ocean, because the ocean has this thermal inertia. It's only partially responded to the changes in atmospheric composition. The warming is larger at high latitudes and low latitudes because there are feedbacks at high latitudes. As ice and snow melt, it exposes a darker surface, and that magnifies the warming. And the map on the left was 2008, and you can see that the Pacific Ocean in the low latitudes was cool, but other places it was just as warm or warmer than it was in the preceding 7 years. Nevertheless, you can ask the question, why should we be concerned about global warming? Because there have been much larger temperature changes in the Earth's history. That's true. But I think I can make clear why this is important. And the basis for our understanding is, first of all, looking at the history of the Earth, how the Earth's climate responded in the past when there were changes in boundary conditions such as atmospheric composition, and also looking at the changes that are occurring now as humans are changing the atmospheric composition. And also climate models are helpful, although I would put them number 3 on that list. And because the history of the Earth is so important, I need to show you a couple of charts on the Earth's history. This shows the temperature, happens to be the temperature in Antarctica, obtained over the last 100,000 years, with time running from left to right. You can see the amplitude of these temperature changes is about 10 degrees Celsius, which is about almost 20 degrees Fahrenheit. So there are large climate changes that occur. This temperature record, by the way, is obtained by drilling a core through this ice sheet. Antarctica and Greenland are covered by ice sheets that build up as snowfall piles up year after year and gets compressed into ice. And from the isotopic composition of that ice, we can tell the temperature at which the snowflakes form. That then form the ice sheet. And also, as the snow compresses into ice, it tracks bubbles of air, so we can sample the Earth's atmospheric composition over this entire time period. And in any case, the climate goes through these cycles, which are big climate changes. We live now in the Holocene, which almost 12,000 years long now, we've been in this interglacial period, a relatively warm period. But these fluctuations are instigated by changes in the Earth's orbit. The Earth's orbit is perturbed mainly by Jupiter and Saturn because they're the heavy planets, and they cause the Earth's orbit to change from nearly circular to slightly elliptical, and they cause the tilt of the Earth's spin axis to wobble by plus or minus 1 degree. That affects the amount of sunlight that's received on the Earth's surface by a small amount, but that's enough to have, over time, a significant climate effect. As compared to 20,000 years ago, 20,000 years ago there was an ice sheet that covered Canada and came down and covered this region too, all the way, and covered New York City and Minneapolis. Those climate changes were instigated by these small perturbations to the Earth's orbit, but the mechanisms that actually maintained the temperature change were changes in the surface reflectivity so they were slow feedbacks that occurred on these long time scales. As for example, as the Earth's spin axis becomes tilted a little more, that exposes the poles to more sunlight. That will melt ice and snow at high latitudes. That makes it a little bit warmer. And as the ocean gets warmer, it gives up carbon dioxide the same way that your Coca-Cola will give up carbon dioxide if it gets warmer. So the amount of CO2 in the atmosphere changes as a function of time as a feedback to this mechanism. But those two changes, the change of atmospheric composition and the change in the surface reflectivity, fully account for these very large climate changes. And now, humans are causing carbon dioxide and methane to increase far outside the range that they've existed in millions of years. And the Earth's temperature is beginning to respond to that. That's the 0.8 degrees Celsius warming that we see so far, but there's more in the pipeline because it takes the ocean a long time to warm up in response to the change in the atmospheric composition. And let me show you one more example. There are even larger climate changes if you look at longer time scales. This is the temperature of the ocean, of the deep ocean, over the last 65 million years, where 50 million years ago it was 13 degrees Celsius, compared with today approximately 0 degrees Celsius in the deep ocean. The fluctuations from glacial to interglacial are the ups and downs of the curve, which you can hardly see because they're so frequent on this time scale. But the changes in climate on these long time scales are due to changes, primarily to changes in atmospheric composition. 50 million years ago, there was about 1,000 parts per million of CO2 in the atmosphere, compared to 385 now. The reason on these very long time scales, the amount of carbon dioxide in the atmosphere can change because the sources of CO2, which are volcanoes, do not need to equal the sinks at any given time. The sink for atmospheric carbon dioxide is the weathering process. As the rivers carry sediments to the ocean, the chemical reactions associated with the weathering that carries these sediments to the ocean deposits carbonates on the ocean floor. That takes CO2 out of the atmosphere. So, and that the source, the volcanic source, depends upon continental drift. So, 65 million years ago, India was still south of the The continent 65 million years ago were almost in the position that we are today, as far as their latitude is concerned, except for India, which was still south of the equator. But it was moving north at a rapid rate of 20 centimeters per year, which for continental drift is very fast. And it was plowing through this Indian Ocean, which had long been the depot center for the major rivers of the world. So the Indian Ocean floor was carbonate rich, and as the ocean floor is subducted underneath the moving continent, the volcanoes put CO2 into the atmosphere, and that's what caused the temperature to increase until India crashed into Asia 50 million years ago. And then the source was diminished, but the sink, the weathering associated with as India pushed up the Himalaya mountains and the Tibetan plateau, the weathering of those mountainous regions drew CO2 out of the atmosphere, and CO2 slowly declined, and the temperature of the planet went down. Well, the bottom line from this, there are two important conclusions. One is the imbalance between the volcanic source and the weathering sink is of the order of 10 to the minus 4, 1/10,000 of a part per million per year. Over a million years, that's 100 ppm of CO2, which is a very big change. But if you compare that with the human-made rate, the human change of atmospheric composition, we're now increasing CO2 2 ppm per year. So we're 10,000 times more powerful than the natural rate of change of atmospheric composition. So humans now are in charge of atmospheric composition. We're determining whether we're in charge or not. The other thing is that 50 million years ago, when the temperature was 13 degrees Celsius, there was no ice on the planet. As slowly as the planet got colder, when it got to 34 million years ago, then suddenly Antarctica began to freeze over 34 million years ago. Well, the amount of CO2, the CO2 had to decrease to about 450 parts per million in order for ice to begin to form on Antarctica. And if we put back in the atmosphere, if we burn all the fossil fuels, put all the coal and oil, the CO2 into the atmosphere, we will be sending the planet back to the ice-free state. It will take a while to get there. Ice sheets don't melt instantly. But that's what we will be doing. We cannot burn all the fossil fuels without creating a very different planet. And we've set up all of our infrastructure as if the shorelines were where they are now. If you melt all the ice, sea level would go up 250 feet. So we can't do that without producing a different planet. And everyone has agreed, all the countries have agreed that we should avoid dangerous human-made interference with the climate. But what does that mean? I think the two most important criteria should be those things which are irreversible. If we drive species to extinction, that on any time scale we can think about is irreversible. There have been global warmings in the Earth's history of several degrees Celsius, and in each case it drove more than half the species on the planet to extinction. And over tens and hundreds of thousands of years, new species evolved. But on any time scale that we can imagine, or our descendants could imagine, it would be a much more desolate planet. And likewise, sea level, it requires thousands of years for ice sheets to build up from snowfall. So if we cause the ice sheets to become unstable, that's an irreversible change. We are beginning to have effects. Already, the Arctic sea ice, it fluctuates from year to year depending upon the weather. But we began to make satellite measurements in the late 1970s, and the sea ice in the Arctic at the end of the summer has been declining in general. And then the last 2 years, it has decreased to a level which is only a bit more than half of what it was 30 years ago. And we're probably going to lose all of that sea ice in the summer over the next few decades because there's more warming in the pipeline, even if we stopped at 385 ppm. If we wanted to retain sea ice in the Arctic, we will need to reduce CO2 to something like 325, 350 ppm. The ice sheet, the stability of the ice sheet, this is, the red area is the portion of Greenland that has melt during the summer. And that fluctuates. The graph shows the area with melt as a function of time, beginning with satellite measurements in the late 1970s. And depending upon the weather, it fluctuates from year to year. But there's been, in general, an increase in the area with melting. And 2007 had twice as large an area as 30 years ago. That meltwater does not, in general, make it to the edge of the ice sheet. It finds a low spot on the ice sheet, it burrows a hole in the ice sheet, goes to the base of the ice sheet, and lubricates the base of the ice sheet, so that the ice sheet then discharges these giant icebergs to the ocean at a faster rate as the melting increases. And although global warming also causes more snowfall in the winter, because the air holds more water vapor as the atmosphere gets warmer. But we know that common sense tells you that as the planet gets warmer, the ice sheets are probably going to get smaller. And that's confirmed now by the gravity satellite, which measures the gravitational field of the Earth with such a high precision that you can determine the mass of the Greenland ice sheet. And the ice sheet gets heavier in the winter, and then in the melt season it loses mass, but overall it's losing mass at a rate of more than 100 cubic kilometers per year. And the West Antarctic ice sheet is also losing mass at almost as fast a rate. So if we want sea level to be stable, if we look at the history of the Earth, the prior interglacial periods, in order to have ice sheets comparable in size to Greenland and Antarctica, we would probably like CO2 to be on the order of 300 ppm. But in any case, at 385, it's obviously unstable, and we're going to lose ice sheet mass. Another effect of global warming is to increase the overturning circulation, the rising motion in the tropics and the subsidence in the subtropics, which causes the subtropics to be dry. That overturning cell will expand as the planet gets warmer. And we observe empirically that it has already expanded by about 4 degrees of latitude. That's affecting the southern United States and the Mediterranean region and Australia, parts of Africa and South America. And so it's one of the reasons why the southwest is so dry recently, and Lake Mead and Lake Powell are only half full. And associated with that intensification of the subtropics is increase in the forest fires, which have in the United States increased by about a factor of 4 over the last 30 years. One of the biggest effects of global warming is going to be on freshwater supplies. The glaciers all around the world are receding, mountain glaciers. And these glaciers provide, as they melt during the summer and fall, they provide a large fraction of the water in some of the major rivers in the world. The rivers originated in the Himalayas and the Rocky Mountains and in the Andes. So the Ganges River, for example, has 2/3 of its water in the late summer and fall coming from glaciers melting. Once these glaciers are gone, and at the rate they're receding, most of them will be gone in about 50 years. At that time, there will be hundreds of millions of people who depend upon these rivers for fresh water who will be in trouble if we continue on that path. The coral reefs are under stress. Coral reefs are the site for almost 1/3 of the species in the ocean. And they are under stress for several reasons, but 2 of the major reasons are the fact that the ocean surface temperature is increasing and the oceans are becoming more acid as the oceans take up more CO2, they become more acid. And the animals that have carbonate shells or carbonate skeletons are threatened by this increasing acidification of the ocean. In fact, they can't live. Eventually, as it becomes more acid, it will dissolve the shells. So these animals can't live in that environment. So all of these things tell us that the amount of atmospheric CO2 that we need to aim for is no more than 350 parts per million. Someplace probably in the range from 300 to 350. And we've already increased it from 280 to 385. Well, if we want to preserve a planet that looks like the one that we inherited from our ancestors, we're going to have to reduce CO2. That has become clear scientifically. And the problem now, and the reason it relates things here, is that if you look at the fossil fuels, the oil we've already used, the purple portions of oil, gas, and coal are the fractions that we have used so far and already put the CO2 in the atmosphere. How much undiscovered reserves there are is somewhat uncertain in the case of each of the fossil fuels, but we've probably already approximately at peak oil. We've probably used about half of the oil. And we're going to use the amount, the easily available oil and gas we're going to use. It's owned by Russia and Saudi Arabia. We can't tell them not to sell their oil. So if you look at the size of these fossil fuel reservoirs, it becomes very clear. The only way we can constrain the amount of CO2 in the atmosphere is to cut off the coal source by saying either we will leave the coal in the ground or we will burn it only at power plants that actually capture the CO2 and put it back in the ground. They can't promise that they will do it sometime in the future. If we did that, if we had a moratorium on any new coal-fired power plants and phased out the existing ones over the next 20 years by 2030, then CO2 would peak at about 400 parts per million if we are at, if we've used half of the oil now. And if the very optimistic estimates for how much undiscovered reserves are more accurate, then the peak CO2 would be closer to 425 parts per million. Well, we can, if the coal is phased out, we can get back to less than 350 ppm within several decades, and we can do it faster if we can get back within several decades if we improve our forestry and agricultural practices so that they soak up more CO2. If we reforest some of the regions that were deforested is the biggest thing that we could do. So it's technically feasible to get back to 350 ppm, but it requires a quick phase out of coal emissions. Globally, it would have to be done over the next 20 years, which probably means in the West you're going to have to do it somewhat faster than that, because we are responsible for most of the excess CO2 in the atmosphere. The United States is responsible for more than 3 times more than the second country, which is China. Even though China's emissions have now passed ours on an annual basis now, but the CO2 stays in the atmosphere a long time. So we are responsible for more than 3 times what China is. So the problem is that fossil fuels now are priced the lowest. And in fact, that's partly because we're subsidizing them. And we're not charging them for the damages that they cause to health, let alone to climate. And unfortunately, it's hard to get governments to make fossil fuels pay their fair share. There's a lot more lobbying for the fossil fuel industry than for the future of our planet and the future generations. That's the basic conflict that we have. Energy departments and fossil fuel companies just take it as a God-given fact that we're going to burn all the fossil fuels. Well, unfortunately, we can't do that without creating a different planet. And as I've already mentioned, fossil fuel interests have a lot of influence in capitalism worldwide. And unfortunately, young people and wildlife don't have nearly as much influence. But we're going to have to figure out, these fossil fuels are finite, so we're going to have to figure out energy systems that are not dependent on these fossil fuels anyway. So why don't we do that sooner and save the planet for the benefit of future generations? I think that, well, we have to try to do it via the democratic process. But it is difficult because, as I've already intimated, the money talks in Washington and other capitals around the world. I think that you're going to see more and more public protest as the public begins to understand better what's happening and as the climate change becomes more obvious. The problem is that we're running out of time. If we go even 10 more years without beginning to phase out coal, it's going to be impractical to get back to a safe level of CO2. And I think it's kind of a curious coincidence. I gave a talk at Lexington several months ago. And Lexington is sort of the place of the first skirmish in the war. Revolutionary War, but the real war started at Concord with a much larger battle. And I think there's been some slowdown in the building of new plants, but it hasn't yet sunk in that we're going to have to phase out existing coal plants, and that will become very clear over the next several years or next decade. It will become clear that we have to phase out existing coal plants. So it makes no sense. So, and that's going to be the real war, because it's so much easier to just continue doing what you're doing. Unfortunately, there's no way that we can get CO2 back to a safe level unless we phase out the existing coal plants, as well as not building new ones, unless they actually capture the CO2 and put it in the ground. And that's why it makes no sense to refurbish old coal-fired power plants, because that's wasted money. Eventually, there's going to be no choice when the public really understands this. As I say, there's this gap between what has become clear scientifically and what the public realizes. But the bottom line is we are going to have to eliminate emissions from coal if we hope to keep a planet that resembles the one that we've had the last 10,000 years. To allow the ice sheets to become unstable, because there are more than 1 billion people who live along coastlines and cities along coastlines. So we just can't do that. Once this becomes crystal clear, the public will demand that, and then it will be much more expensive. It makes more sense now to start now and gradually over. And even that is going to be a difficult job to phase out coal over the next 20 years, but it simply makes no sense at all to refurbish coal plant. I think that's just wasted money. I think I will stop at that point. We can, I guess we're going to have another presentation. Is that right? We're going to have questions.
Thank you, Dr. Hansen. We have 2 U.S. senators who will probably determine over the course of this coming year whether a strong climate bill will be filibustered or killed by coal-emitters. And this very day, also timely, across the street in the Legislative Office Building, our state Senate is grappling with a bill that will determine the fate of one of our old coal-fired power plants, the Merrimack Station plant right near here. And Dr. Hansen has shown us that carbon dioxide pollution is very, very far from free, and that's right now. And in fact, we have 2 preliminary studies quantifying this for New Hampshire ratepayers. If we do not close Merrimack Station, it'll cost them about $100 million more per year to pay for the consequences of putting the carbon dioxide into the atmosphere primarily for the next 20 years. And about $10, to put this down into very graphic forms, about $10 per month for the average residential ratepayer for the next 20 years to pay for some of the consequences that you see here that are going to be internalized. The public is going to demand this. Fortunately, we have some really good news, which is because energy efficiency measures have kicked in so aggressively in New England, in the Northeast over the past 3 years. For example, the light bulbs you see up above here, these CFLs, we have had a wonderful decrease in demand for energy, and the price of energy has gone down, of electricity, and there's a surplus, so that if we wish to, we could simply shut down the Merrimack Station coal plant, and ratepayers would save quite a bit of money. The air would be cleaner, there'd be less mercury in the atmosphere. The other wonderful thing is there'd be more jobs as a result of the changes, and all of the energy we need to shut down that plant is available on the ISO New England grid right now in abundant surplus because of things like putting in these light bulbs. I don't believe I'm going to tap that. So the choices faced by our U.S. and state senators are really political. They're not technical, and we only need to make sure, all of us here, that Dr. Hansen's messages of urgency reaches our 2 bodies. And Dr. Hansen will now take questions from legislators first. There are 2 microphones here. If legislators could go first. We have 15 minutes for this, and then 4 members of the public who wish to.
I'm not a legislator, but I'm the name came up. So my name is Kurt Olson, Dr. Hansen, and I contacted you last year relative to appearing at a conference at our school where I teach a class on global warming. And the interesting thing to me, and I guess I would hope that you respond to this, that students constantly come in, and I guess they're still among the deniers, and will bring in, like, for instance, most recently, this past weekend, the New York Times Magazine had a front cover picture of Freeman Dyson, who I guess is one of the main deniers. And I was just wondering if you could explain to us why there is still traction among those who would deny that global warming is really a problem. People like Richard Lindzen, I guess, at MIT, and Freeman Dyson, and various others around the country, who still are able to get press.
Well, of course, science thrives on skepticism. So every scientist, when he hears some other scientist say something, will naturally be skeptical. That's, and in the case of a person like Freeman Dyson, he has not been involved in climate research, and I'm not surprised that people who have not been involved are skeptical. They need to do their homework and look at the research that has been done. Others like Dick Lindzen and the others who are the professional contrarians, who they are in fact not acting like a scientist. He is acting like a lawyer in that he cites only evidence on one side of the story. A scientist will look at all the evidence and will adjust his opinion as the evidence becomes stronger or as new evidence comes in. But the professional contrarians they keep getting proved wrong on one thing after another as the real world continues to proceed. Dick Lindzen, for example, in the late 1980s said global warming was less than 1/10 of a degree. Well, we now have multiple sources of evidence that show that it's 0.8 of a degree Celsius with a fairly small uncertainty. And he said climate sensitivity was less than 0.3 of a degree for double CO2. Well, now we have evidence from the Earth's history, empirical data, as well as improving models, which show that it's an order of magnitude larger than that. So even though the evidence comes in, they don't change their position. And when they die, they'll probably still have the same position. But the scientific evidence itself has become overwhelming. That's why if you ask an authoritative body, like the United States National Academy of Sciences or the Intergovernmental Panel, you get a very clear answer.
Thank you.
Hi, I'm Jerry Card. I'm the chair of the New Hampshire chapter of the Sierra Club, and we've all followed you over the last 8 years and all the struggles you've been through. I'd like to thank you for all the great work that you've done. It's really been incredible. As Jim Rubens mentioned, we're grappling with the Bow power plant, the Merrimack Station power plant. It's our largest single point emitter of pollution in the state. And at this point, what we're looking at is investing $500 million in sulfur scrubbers to add to the plant. And our estimates that the cost of keeping the plant around for another 20 years could approach $3 billion. And so that's something that's ongoing now, and it seems like this is a great opportunity with you here to maybe speak to that issue of retrofitting and upgrading a very, very old, a 40-year-old coal-fired power plant.
Yeah, you know, one thing I could have made clearer in my talk, now that I think about it. If you look at the size of this oil, gas, and coal reservoirs, what you realize is that because we're going to use gas as a very convenient fuel, and the readily available gas we're going to use, and likewise with the oil. That tells us that we have to phase out the coal. Now, the policies that some governments are still fooling themselves about, they say, well, we'll have some goal for reduction of CO2 emissions. That will not work because the lifetime of carbon dioxide is so long. A good fraction of it there stays there in the air for more than 1,000 years. So you cannot solve the problem by slowing down the rate at which you use these fossil fuel reservoirs. You're actually going to have to terminate the emissions from the one reservoir which you could, and that's coal. And so, you know, I met with the German environmental minister after writing a letter to the Chancellor of Germany. They asked me to come and talk with them, and they kept saying they're going to build they're planning to build 20 new coal-fired power plants. Well, you can't do that. And they say, well, tighten the carbon cap and slow down the rate of emissions. Well, that won't solve the problem. You've actually got to cut off the coal source. And now there's beginning to be a lot of opposition in Germany, and they're having demonstrations to try to stop these coal plants. Well, it's going to become very clear in the next several years that you've got to do that. You've got to cut off the coal source. And that's why policymakers have got to understand that. It doesn't make sense to build new coal plants or to refurbish others, old ones, so that they will last decades longer. Because the only way we can solve the problem is to cut off that coal source.
One other thing with that, could you talk about that it will become clear? Do you mean in terms of cost, internalizing costs of coal?
No, in terms of what the target atmospheric CO2 is. See, we used to think, well, maybe we could live with 450 or 500 ppm of CO2. Well, now, I gave you 5 different things, all of which show that the target has got to be more like 350 that is being accepted by the scientific community more and more. And once that is clear, and once we see more things happening, I also showed you a number of things that are already happening with the climate. And as those become larger and more obvious to the public, then they're going to demand that we do something about it.
Thank you.
Let's try to keep the questions compact so we can get as many as we can in.
I'll start. Bob Perry, State Rep from District 3. This may, I think I know the answer to this question, but I'll ask it. If we were to assume climate change does not exist, are we then released to continue to pollute the planet and contribute to death and disease worldwide?
Well, see, that's a good point, is that coal is just about the dirtiest fuel. And now we are able to capture a good fraction of the sulfur, but the mercury is very hard to capture. You can reduce the amount if you put more money on your filters and things. You can reduce the amount, but you can't. And the pollution associated with coal mining, the regional, the ash piles. There are a lot of health. Air pollution right now kills several 100,000 people worldwide annually. And a good fraction of that air pollution is associated with coal burning. If nuclear power plants were killing that many people, we would close all of them down immediately. But in the case of coal, we're just willing to live with that pollution. It's, but we can't. Well, we're going to have to figure out how to get our energy, as these fossil fuels would run out anyhow. So why don't we do that now? We can solve those health problems as well as the climate problem.
Thank you very much.
I'm Representative Beatriz Pastor, District 9, and I am a member of the Science, Technology and Energy Committee. You've mentioned in your plan a number of points. No coal plants should be built, and then no coal should be burned without capturing CO2 emissions. And eventually, within a time frame of 20 years, we would phase out the use of coal completely. Could you talk to us a little bit about the current state of carbon capturing technology?
Oh, good question.
Yeah, that it's really not ready. It's really the claim that there will be clean coal soon has been sort of an excuse to keep using coal. And the last administration took 7 years to decide where they were going to build the first carbon capture place, because the truth is the coal industry doesn't want that. It will make it more expensive. If you have to capture the pollutants and bury them, that will make energy from coal much more expensive. And so they prefer to say that they're working on it rather than actually doing it. Some people say reality is probably 20 years away. But I think the U.S. has decided now it's going to try to make one plant and try to do it more quickly than that. And that's, we should be trying to make one plant and show how viable it is and how expensive it will be. But that if we put a price on carbon emissions, I think we will end up driving energy efficiency more and renewable energies, and that we probably will end up leaving the coal to the ground.
I'm Representative Timothy Morgan. I represent Durham, and that's actually formerly an employee of Krell. I guess I could ask a strategic question, but I guess a simple technical question, which maybe you can clarify, because maybe I know obviously a lot of, not the people in this room, a lot of people outside this room often misunderstand this deliberately. And I mentioned briefly that global warming causes more snowfall, which is true, but that is often used by global warming deniers. Just about every time there's a major snowfall, they say, oh, global warming is disproven. Look at the blogosphere, the Usenet, you always see posts at outdoors committing suicide every time there's a snowstorm because its theory's been disproven. So maybe, and I guess clarify more that that's actually global warming does cause more events like the major snowfalls and even ice storm we had in December.
Well, global warming causes the atmosphere to hold more water vapor. As the atmosphere gets warmer, it holds more water vapor, just as in the summer, it's much moister than in the winter. So if you're at a place where it's cold enough to have freezing temperatures, then of course you can get more snowfall if the atmosphere has more water vapor. It also means that the line at which you shift from rain to snow is moving poleward, and we observe, in fact, that climate zones are shifting, and plants and animals are responding to that. It fluctuates from year to year because the year-to-year fluctuations are larger than the rate at which it's moving, but temperature lines are moving about 30 miles per decade poleward.
Okay, thank you. Yes.
At the end of December in 2008, you and your wife sent a letter to the Obamas through the then-to-be science advisor recommending national policy, and I would like to know 3 quick answers about that letter. Is it available on the web? Is that still the national policy that you recommend? And does there seem to be any action on your recommendations by the new administration?
Yeah, well, yeah, the letter is on this website where the address is here. Yes, those are the actions that I recommend, and it's still up in the air. The most important thing, and I didn't have time to talk here to get into the question of how you get these policies, but I think a carbon price and 100% dividend is what we need in order to move beyond fossil fuels. For example, if we put a tax equivalent to $1 a gallon, and you put it on coal, oil, and gas at the mine or at the first point of sale, that would generate $670 billion. And I say you should give all of that money back to the public on a per capita basis, which would be $3,000 per adult or $9,000 per family with 2 or more children. And that way, people who do better than average in reducing their carbon emissions would actually make more money in the dividend than they would pay on the increased price of the fuels. And that's the only way that you're going to pressure the system to make the fundamental changes that are needed to move off of fossil fuels. And that's the way that you encourage renewable energies and energy efficiency, rather than trying to demand that utilities use 20% renewables or something. It's much better most efficient economically to put a price on the carbon emissions. And I'm afraid that this is a tough thing for a politician to do, because it sounds like a tax. And it is a tax, but if the money doesn't go to Washington, instead it goes back. You just deposit it monthly in people's bank accounts or their debit card. And if we don't do something like that, I don't think we're going to be able to move off of the fossil fuels fast enough.
Take 2 more questions.
Thank you, Dr. Hansen. My name is John David. I'm from Amherst, New Hampshire. I recently read a book by an author, Gwyneth Cravens, called Power to Save the World. And in that book, she makes a rather strong, convincing case that we really need to look again at nuclear power as an energy, a clean energy alternative, given the zero carbon emissions. I wonder if you'd like to comment on that prospect. It seems that we don't hear in all the iteration of energy alternatives, wind, solar, hydro, and coal
wood chips and so forth. We never hear nuclear yet. 20% of our power in New Hampshire comes from SEMA.
Yeah, I think if we put a price on carbon emissions, energy efficiency and renewables should be at the top of our list. But I think the government should support the research, the rapid, urgent development of fourth generation nuclear power and carbon capture and sequestration, to have those available as options, because it looks very difficult for renewables and efficiency to cover the entire energy need. Although it's conceivable that they could, and they should be at the top of the list. But the present generation of nuclear power plants burns less than 1% of the energy in the uranium. More than 99% ends up in a waste pile, which has a very long half-life and a big problem. But with next generation nuclear power, we could actually burn the nuclear waste. And that would, in addition to solving the nuclear waste problem, it would solve you wouldn't have to mine for uranium for 1,000 years, because we've got enough nuclear waste and existing uranium that, and thorium is another potential source for nuclear energy. And I think that we should at least be doing urgent R&D on that. The Argonne National Laboratory was ready to put together a fourth generation nuclear power plant in 1994, and the Clinton administration terminated that because, you know, there are a good segment of the environmental community is just dead set against nuclear power. I think that, I'm afraid that that will end up forcing us to keep coal plants burning. That's the danger. So at least we should have that option available. And so it's unfortunate, in my opinion, that the Clinton administration cut off that R&D on fourth generation nuclear power.
Hey, Dr. Hansen. My name is John Demos. I'm with the Alaska Wilderness League. I cover the Northeast for the group. And Alaska is warming about twice as fast as the rest of the planet. A lot of coal reserves there, and a tremendous amount of pressure over at places like the Arctic National Wildlife Refuge and off the coast of Alaska. And you were talking about the fact that we could probably do without our coal reserves. What do you feel about tapping these very special places?
Another benefit of putting a carbon price and having a gradually rising carbon price is that I think we should try to leave in the ground. We shouldn't be trying to get every last drop of oil out of the ground. It doesn't make sense, because we have to move beyond oil anyhow at some point. And if we put the price on carbon emissions that is significant and is known, and business and consumers know that it's going to continue to increase, then we will develop the energy sources that are not fossil fuel. And it would make much more sense, because we're going to have to figure out how to get some of that CO2 out of the atmosphere. So it just makes no sense to go to the most extreme environments, the most pristine places, to get the last drop.
Thank you. Thank you, Dr. Here, I'd like to, we have a call to action for the public.
The press and for all of you folks for coming out today. We owe enormous gratitude to Dr. Hansen, not just for going out of his way to come here today, but more importantly for his unwavering dedication and persistence to ensuring that scientific truth and integrity once again provides the backbone of our policy decisions as we move forward into a clean energy economy. Thank you for coming, and Dr. Hansen will now take questions from the press.